Welcome everyone to the Semiconductor Industry Association's webinar series. We know that folks are just starting to populate inside to the webinar platform on Zoom. So we'll just wait about another 30 seconds and we'll kick off today for a really interesting discussion on the fabless foundry ecosystem. So thanks again for joining. We'll be kicking off our conference here in about 30 seconds. All right, we've got a good number of participants now on the line, so we'll go ahead and get started. Again, good morning, good afternoon, or good evening from wherever you're tuning in. We're thrilled to have today a number of really exciting and innovative companies from the SIA membership to talk about where they sit inside the semiconductor ecosystem and the supply chain with a focus on the fabless foundry ecosystem. I'm Jimmy Goodrich, the Vice President for Global Policy at the Semiconductor Industry Association. We represent around 98% of the US headquartered semiconductor industry, but we also have as members around 2/3 of the global semiconductor ecosystem. We are a unique industry that requires deep global collaboration across multiple borders, deep supply chains, and really key international and domestic partners. And we're really thrilled to have that broader set of companies in our membership. Today, I know you all are joining our participants to learn more about what makes our industry unique, in that within one semiconductor industry, there are a huge diverse array of business models, companies, technologies. And we hope by the end of this webinar, you'll come away with a little bit more knowledge about a really exciting segment of our industry, which is called the fabless foundry ecosystem. We'll talk about how this ecosystem came about, what it means, how it might be different from other parts of the semiconductor supply chain, and what are some of the policy incentives or policy actions that government should consider to help further catalyze innovation in this sector, both in the United States and throughout the world. We have several esteemed panelists with us today who are joining us from their around the country here in the United States to share with us some of their thoughts. I will briefly introduce the panelists, and then each of them will provide their opening thoughts for about 5 to 7 minutes. Some of them will have some slides to share, so that should be pretty interesting. Then we'll have a moderated Q&A discussion followed by Q&A with our attendees tuning in online. We are, of course, very happy to have Susie Armstrong, who's the Senior Vice President of Engineering at Qualcomm. She has a long and distinguished career at Qualcomm, has led engineering teams, customer relations teams across the telecommunications industry. And in fact, I was a pioneer in bringing several internet protocols, including the first web surfing on a cell phone in 1997. And today, Susie works in the government affairs group, where she brings an engineering and product background to worldwide policy. James Chen is the Associate Vice President of Product Marketing at MediaTek USA. MediaTek, of course, is a leading fabless chip designer in the mobile application and consumer electronics space. And he leads product marketing for Americas and Europe, spearheading strategic position of MediaTek's products with operators with a focus on 5G and Wi-Fi. He has he studied at UC Berkeley, where he got not only his bachelor's, but master's and PhD in electrical engineering. There's over 30 published papers and 10 patents. Mike Hogan is the Senior Vice President and General Manager of Automotive, Industrial, and Multi-Market at GlobalFoundries, the only US headquartered pure play foundry. Mike has over 35 years of experience in the semiconductor industry. Prior to joining GF in 2019, he was general manager for Cypress Semiconductor for their compute and wireless. He's worked for Broadcom, Avago, Cypress Semiconductor, and went to Syracuse University. Finally, we have Dr. Paul Rousseau, who's the Senior Director of Field Technical Solutions Division at TSMC North America. I'm sure TSMC needs no introduction, but it's the world's largest pure play foundry. And at TSMC, Dr. Paul Rousseau is he handles all of their field technical solutions and supports all the technology engagements for North America customers. And he joined TSMC in 1999, so certainly has seen the company through its rise and development over the last 2 decades, and has a PhD and Master's of Science from Stanford University in Applied Physics. So collectively, we have a lot of really smart minds, decades of experience in the semiconductor industry, who are going to be able to share with us their thoughts and observations about this really critical sector. Just briefly, before I turn to our first presenter, I would just like to add a couple of high-level facts about the fabless foundry ecosystem. So, of course, traditionally, when the semiconductor industry was established, all throughout the 50s, 60s, and 70s, even into the 1980s, most of the companies were vertically integrated, meaning they did everything from the research, the design, the manufacturing, to back-end operations within their own firm. However, starting in the 1980s, we saw innovative business models appearing, both from contract chip manufacturers who would just specialize in the manufacturing, to specialty design firms that started producing a software that companies would first develop internally, but now they develop them externally to customers to help design the chips, to companies that no longer then needed to have their own fabrication facility or fab, and were able to plug into this global ecosystem that has allowed just a tremendous amount of innovation to accelerate, and firms to specialize at what they do best, whether it's just the manufacturing, just the design, just the software. The fabless foundry ecosystem is global, just like the rest of the semiconductor industry. We've got a huge talent base in the US, India, East Asia. There's foundries that are in Taiwan, South Korea, Europe, the United States, and fabless companies that are both large, small. In fact, this is an area where we see a lot of startup activity, is in the fabless chip design space. So it's a very healthy and booming industry. However, we're not without challenges, and we'll get a little bit to that later. There's steep global competition. Governments are placing a priority on their chip design and foundry ecosystem. And we'll talk a little bit later about how do we stay competitive, how do we maintain a healthy fabless foundry ecosystem. So we just wanted to provide some of those opening thoughts before we begin the moderated discussion. And with that, I'd like to invite our first panelist, Susie Armstrong, to share with us her thoughts on behalf of Qualcomm. Susie?
Thank you, Jimmy. It's an honor to be invited to speak on this panel with all of my, not only colleagues on the panel, but people from the industry, this very complex industry that we all work together to make these amazing chips that actually power our world. So I'm going to bring up a slide, just one slide here. It is illustrative of where Qualcomm sits both in the semiconductor industry and the wireless 5G industry. So Qualcomm's the largest fabless semiconductor maker in the world. Notably, we invent the foundational technologies in the wireless area. Most relevantly today in 5G, we standardize them and we design those inventions into semiconductors to bring them to life. And so in this picture, we are probably across all, since 2G days, we are probably the largest contributor to these foundational, the 5 to 10 years of foundational technology research and invention that has to go into creating wireless systems. And then of course, we also we do the R&D and the design in the semiconductors to bring that technology to life. And then being fabless, we work with a variety of manufacturers to actually manufacture those chipsets. So you're probably most familiar with our chips in all generations of cell phones, most of which I have here in my office in San Diego. But we also put our chipsets into automobiles, the IoT, anything that 5G and beyond requires, our chipsets end up going into. So we many years ago made the conscious decision to be fabless from the start. We've never really had fabs in order to focus on that wireless innovation, that R&D and that foundational technology. Again, we sink about 5 to 10 years of research and prototyping into all generations of each generation of wireless systems, and that includes, not just the semiconductors that go into your phone and your IoT, but into infrastructure. We do a tremendous amount of prototyping. We actually used to make infrastructure because when you're proving out a new technology, you pretty much have to do all aspects of that technology. So this foundational technology is sometimes overlooked in the current national narrative about semiconductor manufacturing and shortages. Without this innovation and without this design, an area where the US has very strong leadership, there's nothing to manufacture. However, without a manufacturer, you have no way to bring that R&D to life and to commercial launch. And so, as my colleagues from the actual fabs will tell you, manufacturing semiconductors, especially the kind of complex semiconductors that drive our world today, whether it's your cell phone or your automobile or a healthcare system, is a hugely complex challenge in and of itself. Design companies or fabless companies and fabs have to work extremely closely together, sometimes for months or years, to actually manufacture these semiconductors at a yield that makes them cost effective and makes them actually work. And so we have many strong partnerships with the fabs we work with, including Samsung and TSMC and a variety of, and GlobalFoundries and a variety of fabs. So it's never the case where one company does the design and then you throw it over the wall to the fab and they manufacture it. It's a very strong long-term partnership and technology partnership. So over the last 20 years, we've done this kind of work in this partnership with the strongest fabs in Asia, in the US, and in Europe. And we're very happy to see this increased focus on this complex semiconductor ecosystem and what drives it. And we look forward to your questions and this upcoming panel. Thank you.
Great, thank you, Susie. Now I'd like to ask Dr. James Chen from MediaTek to provide his remarks.
Can you guys hear me? And can you see my screen? So thanks, Jimmy. And I agree with Susie. It's an honor to be here. And I just want to spend a little bit of time, just 5 minutes, just to kind of introduce MediaTek to everybody, because probably not all of you know about us and what we do. MediaTek, we are the 4th largest fabless company in the world. We're headquartered in Taiwan, and we have a US headquarters here. I'm calling you from San Jose, California, the heart of Silicon Valley. MediaTek, we are chipset providers, and our chips power a lot of American innovation in terms of products and services. I just provide just a sampling of some of them and their logos on the left. But to be more specific and to give you some perspective, if you're watching this webinar from your laptop, you're probably using Wi-Fi from MediaTek. If you're in the vicinity of a TV, you look up at that TV, and what's behind that glass is MediaTek chips. We are the largest 4G and 5G SoC smartphone provider in the world. And if you got up this morning like I did and jumped on your Peloton bike, well, then you got to experience MediaTek chips firsthand. So we have over 17,000 employees worldwide across 50 locations. We have a very diversified business. We're not just in 5G, but we're also in wireline technologies. We provide products for the home and also for the business. We look after consumers as well as enterprise. 79% of everybody at MediaTek has an advanced degree. 24% have a PhD. And out of every dollar of revenue that we take in, we spend 24% of that and we pour it right back into R&D. So we're very, very much R&D focused. And that has allowed us to drive this kind of phenomenal growth that we've been seeing. Last year, we grew about 31% from 2019 to 2020. This year, when it's all said and done, we have publicly projected that we'll probably grow at 45%. So truly, we're here to stay. And one of the reasons why we continue in the U.S. and why U.S. companies do business with MediaTek, well, it really comes down to two things. Now, first is technology leadership. In this business, you have to lead technology to be competitive. And it's not just 5G for us in smartphones, but we take, for example, 5G and we apply it to beyond 5G applications. For example, we use 5G to bridge the broadband divide and provide broadband access, which, as we all know, is in short supply, as the pandemic has shown. We are an early adopter of advanced semiconductor process technologies from some of the very panelists that you're going to hear about today. And we are a significant contributor to international standards. And it's not just about wired or wireless like 5G, but Wi-Fi video, we're very strong, as well as other technologies. But more importantly, we are a trusted partner in our customers' eyes. And why is that? Well, we have very reliable technology, and we put a premium on built-in security features. And that has become all the more paramount today. And as an IC, as a fabless chipset supplier, we also have demonstrated a strict adherence, and we have a demonstrated history of strict adherence to regulatory compliance. That's very, very important to do business in the United States. We also have custom design ability to meet very advanced customer specifications, because it's not one size fits all across all our customers. And also, we are committed to grow our U.S. presence because, let's face it, a lot of the innovation, if not most, are really coming from the good old US of A. But the bottom line and key point here is that at MediaTek, we don't make a lot of fuss and a lot of noise. We're somewhat humble and behind the scenes, but we are really the behind the scenes enabler, if you will, of our customer success. With our chips. And lastly, I know I'll make this slide very, very short because I know this is a topic of today, but we really need the U.S. to invest and to have more engineers in order to catalyze and spur this growth of fabless. We are literally in a race to hire new engineers in the U.S. And the talent pool that we have to draw is not as big and as large as we like. And I think my fellow panelists will agree with me. And this is spurred on by new applications. We hear about the cloud, we hear about the AR and the VR, how to hear about the autonomous. Now we have to support the new normal and the hybrid work model. And then on top of that, you have this ever escalating, progression of advanced technologies. So it's unrelenting. You combine that together, drives the need for more technical talent in the areas of chip design, software systems, and semiconductor process knowledge. And we have to secure that technical talent in order to drive the innovation and growth that we want to meet, that we have promised our customers, that we have promised the finance community, and to meet our own strategic goals. And it's a big feedback loop. So anyways, very excited to be here, glad to be on the panel, and looking forward to the discussion.
Thanks, James, and particularly for your thoughts about talent. We really look forward to getting into that topic in the discussion. Next, I'd like to ask Mike Hogan from GlobalFoundries to share his thoughts. Mike?
Yeah, thanks, Jimmy, and thanks for having us here. Glad to go after two of our biggest and best customers, the cell phones or the smartphones that Susie mentioned, and the IoT connectivity that James mentioned are quite often powered by wafers built by GlobalFoundries in our factories around the world. So I feel like we're in good company. So I'll share just a couple of slides to try to set the a little bit of an introduction to GF and a little bit of an overview of what we think the mega trends over the last few decades are driving us towards, and why we're probably all here. So you get the slide to advance here. Oh, there we go. So this chart's interesting in a couple of ways. First of all, it happens to overlay with the existence of the foundry fabless model, and the industry has gone from a very compute-centric world, dominated by very specific markets. Once upon a time the PC, once upon a time the feature phone, ultimately unleashing the power of all things semiconductor with the advent of the smartphone. But now ever more, semiconductors are pervasive in everything you do, in every aspect of life. So the IoT, automotive, the pervasiveness of semiconductors really in everything that touches your life have really changed the game and changed the importance of semiconductors. So one of the popular ways of thinking about chips are that it's really the new oil in the economy. It really is foundational to everything we do. The other overlay here is Jimmy mentioned the world started as IDMs. Because of a foundry model, it was able to foster some fabless startups, some of which have become massive companies like Qualcomm and MediaTek. The IDMs that still practice some of their own manufacturing have almost all become what we call fab light. So they have a mix of internally owned assets and use foundry. And now ultimately here in a post-COVID world, we're really talking about changing an industry that's changing the world. The foundry model has to evolve, and key to that and key to our nation's strategic interests are to reclaim prominence in manufacturing back in the US, and to also understand that this pervasiveness means there's a different definition of what technology innovation is. The vast majority of silicon out there is not leading edge Moore's law. It's pervasive analog, RF, power, all the things that really impact the way your digital life works. So we're very excited at GF, and we really focus on three things. We're a global manufacturing pure play foundry. We're the largest pure play foundry in the US. We're one of 5 foundries that's at scale. So this whole industry is now down to 5 sizable foundries. We're the only one that's truly global at this point. I think others are moving in that direction. Our focus with this pervasive, ever expanding number of customers is on collaboration and partnership across the board. So private and public partnership to put on more capacity, working closely with a broad cohort of customers to make the investments to enhance the feature-rich nature of the silicon we produce. And then really redefining what innovation is in semiconductor manufacturing to mean more than just Moore's law, to mean more than just advancing to the next node, but to truly invest such that the technologies that run 85–90% of the silicon out there today can meet the challenges of the future. And we do this by focusing on traditional high growth markets like smartphone and personal computing, but ever more the infrastructure James mentioned, and the things that now touch your life, like IoT, like your smart speakers, your smart coffee mugs, dishwashers, refrigerators, and then ultimately automotive is going through a renaissance that is become front and center for a lot of us as you hear about chip shortages, constraining automotive supply. But there's a positive side of that. The automotive experience of the future is going to be so much different than the past, and that feature-rich experience, that user experience that the auto will deliver as it becomes electrified and autonomous, is really enabled by the kinds of semiconductors we're talking about. So I'll end it on sort of this note. Our industry is doing a lot. We're investing a lot. This is not a handout as far as public policy. This is reinforcing an industry that was born in the US, that can become prominent and world leading in the US again. But we are investing in capacity around the globe and in the US. And what we need is for policymakers to really go fund the CHIPS Act so that we can do even more. We're pioneering a new economic model for semiconductor manufacturing. The ability to partner to create more capacity has to be hand in hand with incentives for US design companies and supply chain and ecosystem to thrive. You can't just build capacity and hope that the demand shows up. You've got to invest in the entire ecosystem. And I think that's part of what we see in CHIPS and the FABS Act. And then finally, never forget, this is all about the people. These are great, high-paying jobs across the board, whether you're in EDA, whether you're in fabless design, whether you're building state-of-the-art factories in the US, it's all powered by people. So at GF, we've got a really innovative apprenticeship program. We've got an innovative program to bring people from other industries or military service back into a very vibrant workforce. But we need policymakers to support this, with funding in STEM and other things. This is about making things better, not bailing out an industry that's in trouble. And I think it's in all of our interest to do so. So I look forward to the conversation in the Q&A.
Thank you, Mike, for your thoughts, in particular about what the industry is doing to respond to these current shortages and the new environment that we're in. So last but not least, would like to hear our thoughts from Dr. Paul Rousseau from TSMC North America. Paul, over to you.
Okay, morning everyone, and afternoon in the East Coast. Thank you, Jimmy, and thanks everyone for their comments. Agree with most of the comments. So I'm going to go slideless, and I'm just going to have fun with some analogies, right? So I'm going to start with the Olympics, right? If you look at the Olympics, yes, there is the decathlon, but most athletes become very, very specialized in their area, and that's how they become really, really good. Even the decathlon is only track and field, right? They're not going swimming or bobsledding. And the point I'm trying to make is when TSMC was founded, it was founded on the premise that we do one thing, but we do it really well. And that was wafer manufacturing. And with that, there was a corollary, which was, because that's the only thing we do, we never compete with our customers. So 30 years ago, the fabless was just another option out there in the semiconductor industry. And Mike talked about, fabless and foundry going together. Basically, with the foundry model, it kind of created the fabless industry. Fabless existed before, but as an industry, it's really with the foundry model that it came about. And so now if you look 20 years back, the fabless industry was, alive and thriving. 10 years ago, it was like a force to be reckoned with. And if you look at it today, I would say, well, if imitation is the sincerest form of flattery, you will not find a major player out there in silicon, excluding memory, that doesn't have some kind of foundry component. Mike said it as well, right? Even the IDMs, either they have a foundry aspect, they have a fab light aspect. Foundry is a part of every major player out there in terms of their go-to-market and business plans going forward. So I think the fabless foundry model is alive and well, and things are thriving there. And nowhere, I think, is that more clear in terms of the fabless industry than the US. The US embraced the fabless model very early, and I think it's very healthy, and you see a lot of innovation coming out of that. Our goal, as I said, it's manufacturing. And my job is collaboration, collaboration, collaboration. We collaborate with our customers, we collaborate with our ecosystem to create this grand alliance to make things happen. So I want to take a step back now. I'm going to use another analogy. Again, if you go back 30 years, right, and let's say you were some kind of artist looking for a break. The only way you will get a break was if somehow a record label or a Hollywood studio somehow discovered you. All of a sudden, YouTube comes along. And now anyone with a little bit of talent, a little bit of gumption could put something out there. And if they hit something and go viral, they've made it. Not only have they found a new day job, but they're also entertaining everyone else out there. And it's a win-win. And the consequence of that has been a proliferation of different genres in YouTube, right? You get all sorts of different things from, in addition to the funny and educational, now you have how-to videos, exercise videos. There's even an ex-NASA engineer out there who built a squirrel maze in his backyard. I don't know if some of you have seen that. It's hilarious. I don't think it would have ever made primetime before, but it just goes to show the diversity that can be possible when you basically democratize access. And that's exactly what the Foundry model has done, right? We democratize access to the leading edge technology, the specialized technology, the more and more technology. Anyone out there can come and use our technology in a much easier way versus having to create their own fabrication process themselves. Fundamentally, I think we live in a technology world, right? If you look at the 10 biggest companies in the US by market cap, I would say 9 of those are technology companies. And all of that is built on the foundation of silicon. So if we look a little bit more closely at the US design ecosystem, I would qualify it as being quite healthy, right? 2/3 of our customers are based in the US. That's where most of our business is. And when we look at advanced, it's even a higher percentage. I think the spirit of entrepreneurship in the US has been alive and well. We see it in big companies going to new markets. We see it in small companies and startups coming to us. If you look at the biggest company in the US by market cap, it's NVIDIA. And NVIDIA was once a startup with TSMC. So that's kind of been the power of that fabless foundry model. The foundry model has allowed fabless companies, just like those Olympic athletes, to focus on what they really do well. And you can see it in the numbers, right? They spend more R&D because they don't have to spend money on fabrication facilities. So we see our role as providing all of that technology, including leading technology, right? You want the best technology in the world in terms of PPA, power performance area. You can get it from TSMC. And we've helped the ecosystem with our open innovation platform, right? We also call it our Grand Alliance. We have over 40 different IP partners, 20 EDA partners. A lot of those are largely based in the US as well. And we have 6 cloud providers, which are all based in the US. And if you look back historically, going to the fabless, people didn't need a fab anymore, but you still needed 3 things, right? You needed people, you needed computers, and you needed tools. Once you bring in the cloud, you can get rid of the tools and the computers, and all you need is people. So we keep lowering the barriers for people to really have access to technology and create kind of really cool products. And if you look back in the last 20 years, it's amazing how far we've come. And I think if you look forward to the next 20 years, it's going to be even more amazing. Look at what NVIDIA is creating with artificial intelligence, for example. I guess I'll just close by saying that if you were to come up with some report card for how healthy it is, well, you could look at revenues of fabless versus integrated device manufacturers. And integrated device manufacturers are still a little bit higher, but if you added the foundry to the fabless, it's actually a bigger pie. Now, some people would argue that's double counting. But my point is, it's pretty close. If you look forward, which is, for example, by market cap, which is the market's way of saying, how do I look forward on this? Then you see the fabless model and is really, really strong. And basically, people are betting that's going to keep going, and it's still getting stronger. So I'll stop there, Jimmy, and hand it back to you. Thanks.
Well, thanks, Paul. We've had a number of really great and interesting thoughts from our panelists at MediaTek, GlobalFoundries, TSMC, and Qualcomm. Again, thank you, everyone, for sharing your thoughts. So I'm going to now ask a few questions of the panelists that are kind of top of my mind that I've been thinking about, and then we'll in about 10 minutes, open up for Q&A for our panelists who've been able to join us today. So just thinking back a little bit, I think we've touched upon what the ecosystem is and what makes it special. Would anyone like to share their thoughts? Kind of what was the biggest driving factor that forced the creation of this business model? Was it increased design complexity, increased manufacturing costs? Shed a little bit of light into this for us. Who would like to take a stab into that?
I'll take a run at that, and I'll kind of connect it back to an interesting anecdote. So I would fully give credit to Morris Chang, who's the founder of Paul's company. And the reason I know this is a little bit embarrassing. I was actually I started at Texas Instruments back in the day, around the time Morris was leaving to go start TSMC. And the reason I think that's relevant is that TSMC wouldn't have gotten off the ground. The foundry model wouldn't have gotten off the ground. The value created by folks like MediaTek and Qualcomm in the US and Broadcom wouldn't have happened had a government not sponsored that initiative, right? So this idea that public policy can incubate massive value creation, the roots of that stretch all the way back to the mid 80s. When that model was born, and there's no reason we can't learn from that and start a new leg of growth in semiconductor and domestic assured supply right here by learning from what already's worked, and that would be my answer to the question, Jimmy. And I'll yield the floor to anybody else that wants to weigh in, but I remember it viscerally. Older engineers at TI saying, where did Morris go? What is he doing? That sounds crazy, but in the end, 35 years later, here we are.
If I could just build on that, I think public policy plays a really critical role in all of this, and Mike had mentioned this also in his opening comments, but it's not the case that you have a bunch of rich US or Taiwanese companies who can just go off and create more access to foundries, can create more innovation themselves. As Dr. Chen said, the semiconductor industry and the fabless industry puts upwards of 20% of their revenue back into R&D every year, and we do as well. But it's really important. It's really important that the public policy and the public funding actually come through for things like the CHIPS Act, because this whole industry is an ecosystem. As Mike said, you can't have one without you can't have the design without the manufacturing, and it is not the case that you can just throw money at the issue. Another thing that I think Dr. Chen weighed in on was the need for talent, and that's both talent to people with PhDs and people with masters and such to do the design of chips and the design of the software that drive them, but it's also technician level talent, which is not so prevalent these days in the US. Technician level talent to operate these tools in these fabs and be able to come out of schools that are teaching these programs, or we could get to teach these programs and be assured of a certain set of jobs. So I think public policy, tax credits and such are really important for making sure this ecosystem continues to thrive.
Well, thanks both Susie and Michael. Anything else you would like to add to that about kind of how we got here?
Yeah, maybe I can also add a little bit. Yes, I agree with Susie and Mike that government subsidies sure played a role in the beginning of the founding of TSMC, which I believe was about 34 years ago in 1987. But government subsidies aside, no amount of government subsidies will be able to kind of spur, I think, what Morris saw, which was you had a groundswell of applications. And in the late 80s, semiconductor process technology entered a node. We think it's fantastical now to talk about, 6, 5, or even 4 nanometer. Back then, it was 350 nanometer, and that was great. And I think it reached a point in the late 80s where applications started to emerge, beyond kind of traditional applications that people were looking at chips, which is basically memory and some logic. So I think it was a confluence of many things. It was the government getting together. It was the technology, happening at the right place at the right time. And it was also a lot of applications coming online, and Morris kind of brought everything together and kind of ignited it with a fabless model. And here we are today. So.
Well, thanks, James. One other question I
Jim,
wanted to ask.
Jimmy,
Go ahead,
let me
Paul.
jump in real quick. I like Mike Hogan's reference to Morris. It's true, he did learn a lot at TI, and one of the things he learned, if you look at his story, right, was how working with IBM as a customer at the time, he was able to do something really, really well, and that had value to his customer at the time, and that's kind of what that was one of the ideas behind creating this foundry model and really focusing on doing something really, really well. I think going forward, I don't think he foresaw the explosion of innovation that came out of this. I don't think anybody saw it, and it's been really good. But I agree with everybody else. The industry is the oil going forward. And everyone is struggling with, talent and hiring, good engineers. And I think government has definitely a strong role to play there.
Well, in that regard, I actually wanted to follow up and ask a question about talent. A lot of you have touched upon this. And if you think about what is semiconductor design, when a company says they're investing in design, it's really investing in people. It's their engineers, chip designers, layout designers, back-end verification, software and coding. Talk a little bit, I guess, about the challenges your companies are facing right now in terms of trying to meet the demand you have for hiring engineers, and what role governments and universities might be able to play to help increase the pipeline of fantastic talent that our industry needs. I don't know, Susie, do you want to take a crack at that one?
Couldn't get off mute. Haven't learned that in 2 years. I think there's a lot of tremendously good, STEM programs and such starting, we participate very heavily in FIRST Robotics. We participate very heavily in our own STEM programs, for K through 12, for university, encouraging people, to go into these industries and stay in them. But one of the things that we think is missing, and there's two things that we think are missing. Number one, in the manufacturing area, because, with all due respect to GlobalFoundries, the US has lost manufacturing of semiconductors in the US. That creates a dynamic. If the jobs aren't there, the universities don't turn out those people. And so from a manufacturing point of view and an advanced manufacturing point of view, I think it's really important that this work go forward together. There's a lot of interest in fabs on US soil, but in order to hire talent into those areas, you need to have programs in the universities to train that talent and to train, and vice versa. So they're dependent on each other. From the point of view of R&D in engineering in general and software and such, I think it's a little bit more on the side. I'll bring up immigration. I think, we have a lot of people who we have hired from overseas as well as in the US. The industry has been so strong. We've been able to basically bring the best minds in the world to the US to drive this industry. And so I think immigration policy actually plays a big role, in addition to trying to get more US citizens to go into these engineering and STEM fields. Basically, to make it, what I want to do is make engineering and these kinds of careers as cool as sort of creating the next killer app.
Anyone else like that? Anything, James?
Yeah, I like to just dovetail on that. I absolutely agree. I think, to sum it up, maybe toward the end of what Susie said, is we need to bring the sexy back into fabless and in manufacturing. When I'll date myself a little bit. When I graduated from Cal, we didn't it was, people actually went in, there was a lot of focus on chips and hardware. We didn't know what it was an app. The smartphone wasn't invented. A lot of focus is on, hey, you going to IBM Watsonville to do R&D. But then all of a sudden we had fintech, we had the rise of all these apps, web-based companies. I'm not saying that is bad. That certainly has its value and is propelling us forward in time. But the focus now is broader, which is good. But people grow up and they want to go to fintech, which is okay. But we're talking about things and issues that are vital to our national security and infrastructure. Foundries, I think the pandemic has shown us. Chips, the pandemic has shown us, more so that this is part of infrastructure. It's part of how we become stronger as a nation. And I think we just need to bring the sexy back. I'll leave it to the policymakers on how to bring the sexy back, but we definitely need to do that. Or else we're going to lose talent and we're not going to be able to grow. And the United States will not be ahead and we should be.
Well, thanks, James, for wrapping it up there in terms of the talent question. I really appreciate that. I'd like to ask a few questions that we've gotten through the chat box, through the Q&A. And I'll kind of go through these in no particular order, but some really good questions as usual from our attendees, and thank you for that. So one, as we think about the foundry and the manufacturing, think about all that technology happening within the manufacturer themselves. However, can some of the panelists talk about, from the design side, there's actually a significant contribution, design technology co-optimization. This is something that I think outside of our industry, it may not be well known, but maybe Susie, James, talk about, how many process engineers do you have? How do you work with TSMC, GlobalFoundries, other foundries to enable that next generation of process technology? Thank you.
So I'll start and I'll try to be brief because I can go on for a long time about this. So any sort of, Morris Chang was brilliant, and a lot of that partnership also started with Erwin Jacobs, one of Qualcomm's founders, and Don Schrock working with TSMC to be able to make these designs. And so we like to say when there's, especially in a complex design, and especially if you're going to bring up a leading node fab, you need an alpha customer. You need a customer who is willing to put in the year or so work of running test chips to make sure that that you in the fab have that secret sauce, that transistor technology, in order to actually manufacture at yield. You can do anything in a lab. I can do anything in a lab. You can make one chip very easily or relatively easily in a lab, but to make the kind of quality and the kind of volume to manufacture that takes an incredibly talented fab, but it also takes an incredibly talented design company to work, and those two have to work together for a year or more, running tests, doing very practical things, running test chips to make sure that design can actually, those designs can actually, and those two companies can actually work together to have a sustainable fab, if you will. And back to one of my earlier points, it takes a lot more than just money. And in fact, it takes a lot more than just money and a STEM pipeline. It takes the willingness of these companies to work really closely together. These things are really complex, and it's not a matter of just throwing money at the issue. And I'm sure James has comments on this as well.
Yeah. Paul as well, if you'd like to add anything. Mm-hmm.
Yeah, I was going to say, maybe others can respond.
Okay, yeah, I'll jump in. I mean, definitely, Susie, I completely agree with you. And I don't think you train for a marathon, running downhill. I get my day job is to get beat up every day by customers. And it's a good thing, that's what makes us better, right? So we would never be where we are today without the help of our customers, both from their business success, but the fact that day in, day out, they are, working us to death to find problems, fix problems. And that's part of that whole collaboration part I was talking about, right? It's nonstop, but that's how we get to where we are in terms of these technologies are not easy. They're not easy at all. It's just a lot of hard work, and we rely a lot on our fabless partners to help us through and make these things a reality.
So thanks, Paul. One other question we got, a lot of focus in the papers about the CHIPS Act, the support the federal government, the Senate, House is considering for the semiconductor industry. So how do you think the CHIPS Act is poised to strengthen the fabless foundry ecosystem here in the US? And what other recommendations might the panelists have for other additional tools? For example, there's now a proposal for a design tax credit in addition to manufacturing. So maybe Mike, if you want to talk a little bit about the CHIPS Act, and then others want to maybe chime in a little bit about some of the design incentives that could be helpful, Mike?
Yeah, so I think it goes without saying that the CHIPS Act really is, infrastructure for tomorrow, and it's a great start to turning around a trend that if not intervened will lead us with no manufacturing on U.S. soil. So really important that we get this first tranche installed and going. And then I think, like many of us mentioned in the opening comments, and is also sort of a riff off of your question about labor and talent. This thing has lots of really good knock-on effects, right? That, for every dollar you spend on fabrication, that's more wafers to go into more designs, which means more designers, which means more IP. And so really it's this other half of the equation is let's not just build manufacturing capacity, let's invest in the entire ecosystem, because the knock-on effect in high paid jobs all across, limitless in terms of geography, is incredibly powerful. So it's an infrastructure investment for the 21st century that has really powerful knock-on capabilities, and yeah, tax credits for incentivizing folks or encouraging folks to take advantage of what we're doing is just merely doubling down on an already good investment. So we're very supportive of anything that makes the ecosystem in this country more vibrant and more balanced. And right now, chips gets the focus because we've become out of balance on manufacturing. But it doesn't mean that's the only play in town. And we're a foundry, and yeah, we want to partner, and we've partnered in the past to build factories. The most advanced foundry in the U.S. was built by state funding, right? You can do this on the federal level, but you can't ignore the fact you've got to create incentives for demand, and that will have great knock-on effect in terms of high-paying jobs and emphasis on STEM and getting talent into this country, working and thriving.
Anyone else like to add anything to that?
Yeah, maybe I can just add very quickly. I just want to maybe leave a thought. So in a number, which is 50 billion. 50 billion is the number of transistors we can design and put on a chip using the most advanced process. 50 billion is 7 times the world's population. Think about that. Number of transistors on a single chip. That's the complexity that we're dealing with. And so we need an investment at all stages of the ecosystem, right? From the ground up, we need STEM, whatever 4-letter acronym program that we need to bring the level of technical ability up to lead, the world again, to provide that talent. And then on the next level up in the funnel, we need fabless companies to come back again and to get funded by the VC community. We also need the fabless companies from big companies like from SIA and ourselves to also grow, to draw from that STEM, based program talent. Then obviously our chips get manufactured, and we need the capacity which we're sorely lacking now, but 50 billion. And that represents complexity. And you're not going to do this overnight. It's a very complex ecosystem, probably one of the most complex in the world. And we need to start quickly. Just start doing it yesterday.
Thanks, James.
Yeah. So Jimmy, can I jump in on that?
Absolutely.
I think to dovetail on what James is saying, right? 50 billion, that's a great number. That's what we can do on a chip. It's pretty amazing, but it's actually not that trivial to design, right? I've been saying we've been trying to make it easier, but that's still an incredible challenge. And the fact is today, to the amount of money it takes you to make that first design is probably more than what it took you to build an entire fab 30 years ago. So, that's why we support the design credits, right? I mean, it's the ecosystem is healthy, but the complexity keeps getting greater. And we need to help the whole machine to work together.
Well, and I think in particular, we're really excited to see that there's actually some interest in the US Congress about a design credit that would allow to spur that innovation, both amongst small, medium, and large companies to think about this robust ecosystem. One of the areas where venture capital has historically not been too active is in our industry. And hopefully this would help, catalyze private sector investment and others to bring more innovation into our sector. Two final questions, maybe in rapid fire. We're coming up to the hour here. We're getting a lot of questions about one area we didn't talk about, which is packaging. Another key link in the fabless foundry ecosystem. Obviously, we don't have an OSAT here, an outsourced semiconductor assembly test firm, but they're very critical in the supply chain. Anyone like to talk about their role and what are some of the key trends we see moving forward that's going to make this ecosystem stronger?
Okay, Jimmy, let me jump in real quick. We are definitely at the leading edge of Moore's Law, and we feel the pain every day. And packaging is definitely another enabler to kind of keep going down that path, because ultimately what you are building is a system, right? What our customers are building is a system. And so if it can't necessarily be done only by integration on a chip, that's where the system comes in, the packaging comes in. And we see that as kind of one of the next frontiers in which to keep pushing this.
Thank you, Paul. One other question we got, a few questions on is, an increasing trend of both machine learning for chip design and in the fab as well, but also open source, these kind of new trends that are impacting the fabless foundry ecosystem. Would anyone like to take a stab at that question?
I'll take a stab. I think we can learn a lot from what happened in software, right? The open source environment created a groundswell of people having the ability to code. If we critique our own industry, we've lowered the barriers to entry on a historical basis. It's much better than the good old days of trying to launch an IDM from scratch. But I think we have to continue to challenge ourselves that if we want to look more like the software ecosystem, there's more. We can go further. There still are barriers to interfacing with a foundry, to getting access to tools, to getting access to IP, to having a world where IP can be generated and validated by literally anybody, the same way somebody can contribute back to, for instance, Linux. I think some of the challenges for our industry are to continue to do what everybody in this panel has sort of championed, which is to reap the benefits of making access to these assets easier, more automated, more friendly, because that's really what's going to power the innovation. There's no one size fits all, but if we want to foster small companies to have the ability to innovate, we got to make it much easier for them to get access to some of the benefits that we're talking about today. And we've seen the bar go up over time. So if it costs as much today to design a chip as it used to be to build a fab, that is going to be a barrier. So we've got to sort of realize that there's all kinds of different chips that have different entry level points for cost, and everything we do that lowers that makes it easier lets you try things is just better for us long term. At least that's the way we think about it at GlobalFoundries.
Well, thanks, Mike, for helping us think a little bit about that trend in the future and something really fascinating to watch. We're coming up to the hour here. I do want to also give an opportunity for each of our panelists to maybe provide a few 30 seconds of closing remarks. If you were to have our attendees have one takeaway about the fabless foundry ecosystem, we'd like to hear from each of you what you think that is. Maybe James, we'll start with you, then Susie, Paul, and Mike.
Well, thank you, Jimmy, and again, thanks for inviting MediaTek to be on the panel. I think I'll just close with what I said, and also going back to my opening remarks. MediaTek is expanding in the United States. This is the hotbed of innovation. In order for us to do that, we were really looking forward to hiring more talent, engineering-wise, across the whole spectrum of the company, across all disciplines. And we really hope, the STEM initiative, the CHIP Act, and also any tax credit, whatever it may be, if it helps, we're all behind it.
Thanks, Paul.
Oh, yeah. So let me go to an analogy again. I think if any of you have ridden an e-bike, you know that they can be a whole lot of fun. You can go farther, you can go faster, you can go to new places, and you have a whole bunch of fun doing it. To me, it's like, TSMC is like an e-foundry, right? We try to enable our customers to go farther, to create new products that were never before possible. And, it's obviously it's a working system, but it's a fragile system. It's needs a lot of money, a lot of resources, and anywhere the government can help there, I think is positive, because this is a fundamental industry that is just, transforming the world.
Thanks, Paul. Susie, and then Mike.
I just would like to echo what other folks have said. It's design and build is an ecosystem. And public policy needs to support that ecosystem. It's that ecosystem that drives innovation, especially in the US. And anything that the public policy can do, be it support for STEM, be it tax credits, is really helpful in that ecosystem.
Thanks, Susie. Mike?
Yeah, Jimmy, I would just leave on the obvious, right? Which is let's start by taking the first step. Let's get chips funded, and that is a down payment on what we can do in the future. I think the importance of semiconductors in the lives of the people in this country, in the prospects for the country economically, are sort of inarguable. But now it's time to act. And remember, we're not alone. There's other governments and countries around the world that see the same picture. So I would just implore us to use the fact that this is an issue that has bipartisan support, unprecedented bipartisan support. If you think about it on a relative scale,
A rarity.
So let's not lose the momentum. I don't know if we're making it more sexy, James, or more cool, but this is getting ahead of a crisis. This is not a bailout. This is an opportunity. Let's get ahead of it before it becomes a crisis. When we wake up and we say, "Oh my God, there's no 5G infrastructure in our country anymore to buy from," right? We can avoid that result in semiconductors, and this is the best chance to do that. So let's just take that first step and do all the other things that go along with it: STEM and people and jobs. It's got something for everybody in there.
Well, thank you, Mike, Paul, Susie, and James from MediaTek, Qualcomm, TSMC, and GlobalFoundries. Really happy to have all of you here today for sharing your thoughts about what just makes the fabless foundry ecosystem so unique. I think we had a tremendous amount of great questions from our panelists, from our attendees. Shows just how much interest there is in this topic. And I would encourage all of you, if you want to learn more, visit our website, semiconductors.org. We have a number of white papers and studies that help you better understand what makes this industry unique. And stay tuned. We have more webinars coming on a variety of different topics. So thank you again to our panelists, and thank you for our participants for great questions, and look forward to the continued discussion. Thank you, everybody.
Thank you.
Thanks, everyone.